Okay, so you've been assigned a lab where you need to figure out an average, graph it, figure out standard deviation, and then do error bars on the graph. So we're going to use the shoot the sheep lab from Bio A. And if you remember, we shot the sheep under two different conditions, eyes open and eyes closed, and we did 10 trials for each. So whenever you have 5 or more trials, then you are going to do standard deviation. So first thing we'll do is the average. So I'm going to click in this box right here, and I'm going to put the average for eyes open in that box. So what I'm going to do is go up to this where it says auto sum, but I'm going to press the little arrow, which gives me a drop-down box, and I'm going to click on average. And automatically it will highlight all the data here, so I don't really have to highlight that data. I just have to hit enter. And right now that gives me the average for the data for eyes open. Now I want the data for the average for eyes closed. Well, I don't have to go through the whole process again. All I have to do is go here to the bottom right corner of this box until I get a black cross, and then just drag it over to this column here, and it will give me my average for there as well. Alright, now I want to do the standard deviation, and I'll show you how to calculate it first and then explain what it means in a bit. So I'm going to do something similar. Highlight my box here, but this time I'm going to go to Formula Builder up here. Now for me, STDEV, standard deviation, appears because I'm a nerd and I use it a lot. If it doesn't for you, just type in STDEV here and it will pop up. And go ahead and double click it and you'll get a box here. Now I don't want that there. I don't want my average included, so I'm going to go back and highlight columns 2 through 11 and hit enter. And that will give me my standard deviation here. Go down to the lower right corner, I get my black cross, drag it over. That gives me my standard deviation for eyes closed. Now I can go ahead and get rid of that. Now I'm going to want to graph my average. So I'm going to highlight the two boxes here for the average, and I'm going to go over here to charts. Now for this particular set of data, a column graph is going to best show my data. So I'm going to hit column, click there, and it graphs my data. Alright, so now I've got standard deviation numerically. Sometimes it's better to see it visually. So those are called error bars. So I will click on my graph, I will go to chart layout, I will go to error bars. I'll go to options, I'm going to go to custom and specify my value. Now I'm going to get rid of what they have here, and I'm going to instead highlight my standard deviation for both columns for the positive error value, and I'm going to do the same for the negative error value. And I'm going to go ahead and hit OK, and then I'm going to hit OK, and these are my error bars. Okay, so what is standard deviation all about? Well, standard deviation tells me how reliable my data is. And what I'm going to do is I'm going to compare it to my mean. So I can do it numerically here, or I can do it visually with the error bars here. Numerically, what I'm going to look for is how big is the standard deviation number compared to my mean. And if it's a low number, that means my data is reliable. What it means is all of my individual pieces of data are clustered very closely around the mean. And you can see that if you look at the data. My mean is 0.331. So let's look at some of these values. 0.334, 333, 334. Very close to my mean. Now some are farther away, but overall this is very reliable data. The error bar also shows this. If you look, the error bar is very small. That's very good. So my data is clustered very closely around the mean. Now let's compare that with eyes closed. Here, my standard deviation number is larger than the mean. That's definitely not good. My data is definitely not reliable. And you can look, the average is 0.797. Well, some of my numbers like 3 0.233, 0.234, those are ridiculously far from the average. How reliable is this data? And with the shoot the sheep, if you remember, that 3 seconds is a penalty for you hitting it before the sheep went. What this means is that 3 seconds a good indication of your reaction time? No, it means you made a mistake. So when your number is higher than or close to your mean, it means your data is not reliable. And this is also shown by the error bars here. Look how big this error bar is. The values are anywhere from here to here. So that means my data is not reliable. Now that's something you're going to want to comment on in your conclusion when you talk about how reliable or how good your data is. The other thing you're going to want to keep in mind is units. Your unit for your average is going to be the same as your unit for your standard deviation, or vice versa. So please make sure you put a unit for standard deviation. It's the same as for the average. I hope this helped, and if you have any questions, please come and talk to me.